In this video, I'm going to show you the steps of how to find limits graphically. If you're looking for a detailed walkthrough of how to solve these problems, please refer to the video that I attached below. Now let's go ahead and get started. So to really understand how to find limits of a function graphically, you just need to understand these three things, and everything kind of builds on top of them. Before we start solving, you just need to know a couple pieces of notation, which I'm going to go ahead and highlight right now. So depending on the format of the number that x approaches, that's going to determine how you find your limit. If there's a plus sign to the right of the number, the limit is following the line from the right side of that number. If the limit says follow x from a number with a minus on the right side of it, you need to follow the line from the left side of that number. And then finally, if the limit says x is approaching some number and there is no sign to the right of it, that means you must find the limit from both sides. There is a special note here saying if the limit from both sides is not the same number, the limit does not exist. Now let's go ahead and apply these ideas to some of the problems. In this first example, the problem wants us to find the limit of the function as x approaches 4 plus. 4 plus means 4 from the right side of the line. I'm going to go ahead and mark 4, and then I'm going to mark from the right side of the line, like so. If you look at the diagram now, you will now realize that as x approaches 4, the line from the right side approaches the y value of 2. So in this case, the answer is 2 for this limit as x approaches 4 from the right. So now if you take a look at the problem below, this limit says find the limit of the function as x approaches 4 minus. 4 minus meaning from the left. I'm going to go ahead and mark the diagram, and then you'll be able to find the limit. In this problem, once again, the line of the function to the left side of 4 is approaching the y value of 2. So the y value is still going to be 2. Notice there were no holes, there were no closed points, there weren't any asymptotes. You simply just need to follow the line. Even if there was an open point there, the limits would still be equal to 2. Now, in this example, the problem wants us to find the limit as x approaches 6 minus, meaning 6 from the left. So it'll look something like this. When we look at the line as it approaches 6 from the left-hand side, notice that there is a open point exactly at 6. But once again, where does it look like the line is approaching? It's just 1. So the answer for 6 minus is going to be 1. Now in the problem below, it wants us to find the limit as x approaches 6 plus, meaning 6 from the right. So the line from the right is going to look like this. What y value does this line seem to approach? It doesn't look like it's slowing down, so the y value of this line actually approaches positive infinity. It's possible to have infinity as an answer, and it'll either be positive or negative infinity. Now look at the next example. Looking at this next diagram, it's asking us to find the limit as x approaches 6 signless. So that means from both sides. I've already marked out the lines from both sides, and we also have the numbers to the right. For us to have a limit from both sides existing, the y values need to be equal. Since one of the limits is equal to 1, one of the limits is equal to infinity, the limit can exist from both sides. So the answer would be D and E. A simple way of thinking about the limit from both sides, if it exists or not, the line has to touch the same exact y value from both sides. If it doesn't touch the same y value, the limit does not exist. Now let's move on to other examples. For this example, limit of f of x as x approaches 7 plus means 7 from the right. So it's going to be this part of the line. At the x value 7, it does have an open point, but we don't care about that. The line looks to be approaching the y value 2, so the answer is 2 in this case. Now in the next problem, it's asking us to find the limit as x approaches 2 minus, meaning from the left. If we follow the line from the left side, notice the line still approaches the y value of 2. Even though there's a closed point, limits aren't defined where the functions are defined. It's only where the line approaches. So the line is still, or the limit is still equal to 2. Now in this next problem, it wants you to define where the function is at. So you just take a look at the x value and you notice wherever there is a line or there's a closed point, that's going to be your answer. So when I mark it up like this, we notice that there's a closed point at y equals 3. So the function is going to be defined at the y value of 3. Now for the next example, notice that x is approaching 3 signless, meaning from both sides. So when we follow the lines from both sides, ask yourself, are the y values the same? Take a look. Don't be fooled by this problem. Just because there's a close point at 3, that doesn't mean the limit actually exists from both sides. We only care about are the y values the same from the left and right-hand side. Notice the left side is equal to 2, and the right side is equal to 1. Since they're not the same number, the limit as x approaches 3 from both sides does not exist. So now in this last problem, notice that x is approaching 4 signless, meaning from both sides. So let's go ahead and take a look at the lines from both sides and let's see if they give you the same y value. Now at x equals 4, it does look weird that there's a little corner at that value, but at the end of the day, do the lines touch the same y values from both sides? If we look at the pink arrows, the answer is yes. So the function is defined from both sides, and it's going to be the y value of 2. And that covers the basics of how to think about limits graphically.